College art textbook chapters 3 and 4. I made this slideshow myself to try to condense 2 chapters really, because the 2 chapters were highly related, talking about the elements of art and principles of design. So this should kind of wrap up those 2 chapters for us. On the first question on your worksheet, it says, actual line is easy to understand because it is just a simple line. Like it's a line that's actually there. Implied line is a little more complicated because it refers to a line that your brain processes, but that line isn't actually there. So, answer for number 1, implied line refers to a line that your brain processes, but that line isn't actually there. The 2 examples on the slideshow, because we recognize Pikachu from pop culture, it's an interesting picture that this person made because they didn't put in most of the outline, but yet there is enough there for our brains to be able to see the shapes. And so in our brains we can process, the posture and, the sense of movement, even though there isn't line there on the paper. So that's an example of implied line. The picture of the person standing there to the right side is very similar, where we've got a lot of curved lines, and the curved lines kind of define, the muscular shape and the skeleton shape of the human standing, but there aren't actual outlines that go, on the shoulder down to the arm or etc. So that is another example of an artist using implied line in order to demonstrate shapes. They don't have to literally draw the line in every case, in the art world. So, second slide is on shape. The question on the worksheet says, shape is 2-dimensional. You can make art based on shape. Why is the shape-based art on the right more interesting or effective than the shape-based art on the left? So, shape, we've talked about already this year, and I don't need to go into detail, so really all I want to think about here, the artwork that is on the right is a more effective artwork, all right? And effective is like a soft word for it's good, and the other one's not very good. So, if you hung these 2 up in a museum, for example, you would probably look at the one on the right, and it might not be your favorite work of art, but you'd be like, oh, that's cool. And then if you saw the one on the left in a museum, you'd be like, why is that there, right? Well, the reason why, and here's the answer for number 2, if you are going to use shape in your art, our brains want the shape to be very clean. And you're like, okay, what does that mean, clean? You don't want it to be sloppy, okay? So if shapes are going to be shapes, make them clean. Make them very geometric. And that's not a universal rule, but it's a general rule. So it's kind of like you set the bar high. If you're going to set the bar high because you're basing your art on shapes, then you better have the shapes be like very clean. So hopefully that makes sense. Number 3, space. On the worksheet says, space is simply how an artist uses the space they have on their art. So space could be like in painting, it could be in drawing, it could be in sculpture. Space could be 3-dimensional. I'm going to focus specifically on a type of art that's called positive and negative. And some of you have probably done a little bit of positive and negative art with me at one point. The idea behind positive negative is that it is focusing more on this concept of space. So an artist doing positive negative art, they are specifically like focusing in on the aspect of space. Positive space is like the main object or the main subject in your art. And then the negative space, so that the negative part refers to the background. That's kind of around your main subject or object. So the answer for number 3, what makes positive and negative space art interesting? And the answer to that is that in most art, there isn't as high of a focus on space. In most art, there isn't as high of a focus on space. But in positive negative art, there is. And that's a real simple answer, but you don't have to write this, but I'm going to give you more details on what that means. So the picture that is on the right-hand side, where it's the city with the cords and the light bulbs. So much art that is out there, it just has things going on in it. You just put things everywhere. Like, if you do a picture of a landscape, there's going to be trees and things everywhere. And so the focus of the art is to make those things, your main subjects, look real, and you're not really caring about the background. Well, in positive negative art, the background becomes just as equal or just as balanced or just as important as the main subject. So in this city, if you were just trying to simply make a city look realistic, like this one does, but this one has more of a emphasis on the background. So the black background becomes a hugely important part of the artwork, and it's not just about the yellow lights that are in the buildings or the ones that are dangling. So in most art, you kind of just neglect the background and you just focus on your main subjects. But in positive negative space art, you are actually paying attention to all of the spaces, not just the main subject spaces. You're also paying attention to the background spaces. All right. Number 4, value. Been dealing with value since you guys were in 7th grade. That was like a huge thing in 7th grade and pretty much every grade since then. So I don't need to over-explain it. The question that we're supposed to answer is, lots of artworks have shading. Why are these 2 artworks examples of emphasizing value in art? So it's like, yeah, Mr. Richter, every artwork for the most part has some shading. Maybe not every, but most. And so what's the big deal? Well, these 2 works of art emphasize value because really, and some of you are going to laugh at this, but really the drawing and the shapes and the form parts of the art are simple. So since everything is simplified, the only thing that's not simplified is the shading. So I know that not everyone can draw people very well, but like in the person, the picture that's on the left-hand side there, the person's face and kind of like they didn't get real specific on the details. It's like one of those pictures where I'm sure they based it off of someone, but it could be like a million people kind of would look like that because they simplified the other parts of the drawing in order to emphasize the shading. So they simplified everything else in order to emphasize the shading. And the picture of the plate and the fork, it's kind of the same thing where it's like it's really not that complicated to draw a fork. They didn't draw it perfectly realistically. There's a couple lines or details that the angles are off a little bit. But they were very focused on getting the shadows and the highlights and the midtones. So these 2 works of art are definitely focusing on value, and they're kind of like less emphasizing other parts of art. So that's why, hopefully that makes sense. Number 5, why is it so complicated to see color? Why does it take training and such an eye to, as Richter calls it, think beyond the box of Crayola colors? All right, so this is a phrase that I used a bunch, especially in 7th grade art, when you guys were learning how to paint for the first time. I tell the kids to try to mix like a cool blue or like a nice green rather than just taking the colors straight from the bottle. Because literally, I'll have my kids hang up their 7th grade art paintings, and if I'm not careful to teach them and drill that into their heads, literally every red, literally every blue, etc., on the wall where their art is hanging is going to be exactly the same on every painting. And then if you look at professional artists, they hardly ever have like the exact same blue from one picture to the next. That's because they're just, they're more trained to look at color. And it's complicated to get that training. So when I say think beyond the box of Crayola colors, I'm meaning, you get like the standard 12 or so colors. And many artists, even seriously like talented high school artists that even get first place in the art show, for example, even they oftentimes never grow to think beyond the box of the 12 main colors. You can still be a good artist if that's the colors that you use, but to be like, superstar, I guess is what I'm talking about here. I'm just going to read from this slide here a little bit, and then I'll give you the answer for number 5. The color that we actually see depends on lighting. The example I always use of that is like if you had like purple walls in your bedroom and you turn the light off, you wouldn't see the exact same purple. And if you turned a yellow lamp on, a yellow light bulb, so you turn the yellow light bulb on, and that actual purple, it's still the same purple obviously on the wall, but it should look a little different because of the yellow lighting. So if you were to like take a picture of it and drop it into Photoshop and then shine a white light on that same purple wall and then drop that into Photoshop, you'd be able to see on the computer screen that it was the same purple wall, but the quality of lighting actually changes the actual color. Now, the average art student, and honestly, most artists who struggle with this type of thing, if they were painting that picture, they would have a hard time saying, because this purple wall had a yellow light on it, that should adjust the way that I choose colors here. Most artists wouldn't be able to do that. So that's why it's really tricky to have like photorealistic color in your art. It's really hard to, quote unquote, think beyond the box of Crayola colors. So I guess I kind of answered the question there, but if you were still looking for an answer for number 5, it's really difficult to think beyond the 10 or 12 standard colors. I don't know if that's if you went to college and used that in an art paper, that's probably, your professor probably wouldn't accept that, but since that's how I explain it to you, I think that's fine. All right, moving on, number 6. Still kind of on that idea that color is hard to read. It takes a lot of thought and skill, and our brains process it differently on a subconscious level than we are able to on a conscious level. So here's a painting from Salvador Dali, and it's called Duck. And you can see that due to the lighting, the picture looks green. It's like, why? Like our brains process this, and we know that the duck's feathers are much whiter than they would be green, but we can tell the whole picture is kind of washed green. It's kind of like when someone posts a picture on Instagram, or maybe they send a selfie or whatever, and there's just this like weird glow to the picture. Your brain doesn't say, my friend that sent this selfie, they have green skin. I mean, their skin might look green in certain lighting conditions, but your brain knows that that's not what's going on there. So your brain is able to process the color, and even though it literally looks green, your brain says, well, I know, I can see that there's a wash going on in the whole picture that looks green. So your brain still interprets the color, of the feathers on this picture as white. So for number 6, this is a good example because, I guess, how would I say this? Our brains, I'll use the quote from the slide. Basically, our brains simplify our environment in order to process it. So we simplify color too. So our brains simplify our environment in order to process it, and part of that is simplifying color. All right, hopefully that makes sense. Next one. This is a famous example. It's from a number of years ago now, so you guys, some of you might have been pretty young when this came out, but the dress that went viral. So there's a photograph that became an internet sensation when viewers disagreed over whether the dress that was pictured was colored black and blue, or is it white and gold. So it's more fun to have this slide up as a class, because every year that I've had this slide in 5 years now worth of art classes, and there's always like a pretty even 50-50 split on how people interpret the color of this dress. So number 7, simply just write what color scheme you think it is. Personally, I interpret the dress to be a white dress with gold, but it's just hilarious how it's so evenly split. So this kind of relates to that whole science, kind of like the duck, where there's like a weird lighting situation going on in this picture. You can see how bright and yellow and glowy the background is, and then you can see that there's probably less light on the dress. It's like in a darker spot of the store or whatever. And so your brain is using that information and trying to interpret what color the actual dress would be. Number 8, I put a quote in here about like the psychology, basically, of looking at this picture. Neuroscientists Bevel Conway and Jay Netz or whatever believe that the differences in opinion are a result of how the human brain perceives color and chromatic adaptation. Conway believes that it has a connection to how the brain processes the various hues of a daylight sky. And the quote, "Your visual system is looking at this thing and you're trying to discount the chromatic bias of the daylight axis. People either discount the blue side, in which case they end up seeing white and gold, or they discount the gold side, in which case they end up seeing blue and black." In other words, this dude's obviously very smart and talks all nerdy. What you should write for number 8. There are 2 general ways that photographs, especially, end up appearing. One is that they have a yellow tinge, and the other is that they have a blue tinge. If I've ever had a chance to teach you advanced Photoshop, and honestly this was on my to-do list for college art this year, is for us to have this lesson up in the Photoshop lab, so hopefully we can get back together. When you get a photograph, and oftentimes phones are the worst ones, but it can happen on a professional photography camera too, where you take a photograph and it'll either go towards the way that the picture looks too yellow compared to how the actual scene looked, or sometimes the picture goes too blue towards how the actual scene looked. So I don't really understand the deep scientific explanation for that. I just know that as a photographer, if I take a picture and I look at the coloring, sometimes I have to add a subtle blue, because if it's too yellow, then you have to add blue. And then if the picture looks too blue, then you have to add yellow. So it's like they end up balancing each other off or out. And that's kind of what's happening in this dress picture, where your brain knows that photography goes either towards blue or towards yellow. So then you're trying to guess in your brain what adjustments need to be made in order to see the true color. Number 9 says, if the world and art was just purely local color, then we wouldn't see ... Local color is the color that you expect something to be. So this example that I put on the slideshow is an orange, and you expect an orange to be orange. Seems pretty simple, right? But then if you see the 3 boxes of color that are kind of pasted over the top of the photograph, some of the orange is actually like yellow, and then there's a section of the orange that is pretty much like a true orange. And then when you get towards the shading side, the shadow side, it's brown. Okay? So, an artist knows the local color of an orange, but an artist is also able to say, well, yeah, an orange is orange, but I need to put like a bunch of yellow for the highlight, and I need to put some brown for the shadow. The answer for number 9 is if we only went with local color, everything would look flat. So if we only worked with local color, everything would look flat. It's kind of like when little kids make art and they just color everything from the Crayola set. So a reference to a few problems ago. All right, number 10, summarize the 3 steps of painting. There's a lot of big terms and stuff in these. There's actually 2 slides in order to get number 10 in. The simple way to say this, the first step, A, is using the local color. So I was just bashing on local color because it makes your art look flat. But when you start a painting, you start with the local colors. So if you had an orange in a basket, your first layer of paint is you would paint the brown, just like pick a straight up brown and paint the basket brown. Then pick an orange and paint the orange that color, orange. The second pass, and so this is B, you go in and you start to be a little more perceptive about the details in the painting. If you were painting a basket with an orange and it was under a candle, you might throw in a little bit more yellow than you would have if your basket was outside in a thunderstorm, okay? Because the yellow candle would give more of a yellow vibe, and being outside in a thunderstorm, you'd take your orange and you take your brown basket, and you'd probably actually start adding a bunch of shadows to it because the thunderstorm would be kind of dark. So that's an example of B. And then C, the last thing, is really fine-tuning. You can just write fine-tuning for C. So you kind of take a step back after you've put the local color, which was step A. B is like lighting conditions, and C is like fine-tuning. Number 11, summarize optical color mixing. If you look at the chart on the slideshow, optical color mixing is when you are seeing colors in a certain way, even though that's not necessarily how they are. When you are seeing colors in a certain way, even though that's not necessarily how they are. And what that means, it's kind of like when you take a picture on your phone, and if you zoomed way in, I'll use like a red sweatshirt. You're wearing your Red Jags sweatshirt, and someone takes a picture of you, and you zoom way in on your Red Jags sweatshirt. Chances are you're going to see like a lot of gray and brown in like the shadow areas of the sweatshirt. And then like the pixels for the brighter areas of the sweatshirt might actually look like kind of like orange. So your brain doesn't see, oh, there is, brown in the sweatshirt. Your brain sees a red sweatshirt with some shadows. But if you zoom in real far on it, the actual color that's there is brown. So that's what optical color mixing is, because your brain mixes the colors together even though it's not the colors that are actually there. All right. Number 12 is an example. And honestly, I don't know how to pronounce this French painter's name, so I'm not even going to try. But his career was all about optical color mixing, at least all the paintings of his that I've seen. So Here's an example of a picture, and then on the right hand side it's zoomed in so you can see the details a little bit better. Where he just, it's called stippling, where you do the dot dot dot. Pointillism is another word for that. So as a painter, this dude went in and dot 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 dot, a bunch of different colors. And when you zoom out or step away from the picture, it kind of comes together. It's much smoother. I wouldn't say it's smooth, but it's much smoother, and your eye blends all the colors. And then when you do the zoomed in version of it, you can see each individual color, and it's almost like, why did he put that color there? It's really confusing how there's all those colors there, but it still makes sense and it looks right. So that's an example of optical color mixing, because there's a variety of colors, but when your brain processes it, it kind of simplifies it. For number 13 and 14, I am throwing a video into here that I normally show in class, and hopefully get the answers out of it. I think what's more important than the answers for 13 and 14 is the demonstration that it has.
This is additive color. The additive primaries are red, green, and blue. I've marked them in such a way that the colors are written here. Red is 100, green is 010, and blue is 001. I'm using 0 to 1 space to represent what you normally think of as 0 to 255 in 8-bit Photoshop. But I'm using ones in this case. The way that additive color works is the primaries add together. So if we make this have the linear dodge or add blend mode, and this have the linear dodge or add blend mode, and we do the same with the third color, then we can take these and add them together. Red and green make yellow. Here you can see 110. Red and blue make magenta, 101. Green and blue make cyan, 011. And if we add them all together, we get white, 111, and a full color image. These are the subtractive color primaries, cyan, magenta, and yellow. I've marked them in such a way that you can identify them by putting a white circle over the color separations that exist in this example. Cyan contains no red, but it contains green and blue. Magenta contains no green, but it contains red and blue. Yellow contains no blue, but it contains red and green. If we want to combine these subtractive colors, we need to use the, this may surprise you since it's called subtractive, but we use the multiply blend mode. Multiply, set this to multiply, and we set this to multiply. This is because what we call subtractive is really mimicking how a color transparency works if you sandwich them together, where white is clear and the color is like a colored filter, like a cellophane or some sort of a gel. So if we take cyan and magenta and multiply them, you can see they combine to make blue, and blue is the only surviving white dot here. If we take cyan and yellow and combine them, we get green, as is indicated here by the white dot. If we take magenta and yellow and combine them, we get red. There's the white dot. And if we take the red and the cyan and combine them, when all colors line up, they make black and a full color image.
Number 15 is more fun to do in class, because I usually do this on the overhead, but I am going to try this on the video. So what you need to do in order to understand the concept of after image is this picture on the screen right now. And right in the center, there's 4 dots. And they're really small, but just look right in the center. And I need you to focus on one of those dots and just stare at it. And you're going to stare at it for a while. And keep staring at it. Keep staring at it. Keep staring at it. And boom. All right. So if you did that the way you were supposed to, the after image of Jesus shows up. So there you go. You see Jesus. The next one, again, same concept. Stare at that dot right in the center there. Stare at that dot. You're staring. Still staring. And boom. For a split second there, the after image of the actual red, white, and blue American flag should have flashed in your vision. So this kind of relates to like when we were looking at pictures that had all the dots, like that painting of the boat. Your brain tries to make sense of color, and sometimes it's not a perfect process. You can't believe everything you see with your eyes, right? You can't trust your eyes. Can't trust eyewitness accounts, stuff like that. So it's just an interesting, subtle gray area in our sense of vision. Moving on to number 16. Describe how sometimes the actual local color isn't the best choice for your art. And describe some tricks to use color better. So, as an artist, your goal is to communicate something to people. I put this picture on the slideshow because I think of the road trips that I've taken out west, through the Rocky Mountains, through the, down south to the desert, even up north to Montana or Yellowstone National Park. And you take a nice camera with you, and you take the pictures, but the pictures are right, but it just doesn't get that full effect of how magnificent and beautiful it actually was. And so that is an example to me that if I'm an artist, sometimes in order to make it look as magnificent as it actually is, I am going to probably alter a few things. So I might make the mountains a little bit taller because that's how they seemed in real life, even though that's not how they seem on a picture. I might make the greens a little greener or the blues a little bluer. So as an artist, you make decisions like that because you want to send off a vibe or a message that's powerful. All right? So sometimes you use some of those tricks of making things brighter or more saturated in order to get the spirit to just jump out on the picture. All right, number 17. Surreal color. What impact does having an extraordinary color have on an artwork? Here's 2 examples. Dan Flavin, his artwork is conceptual, so he uses a lot of lights and lighting in his artwork. And the pictures are way less cool than actually seen in person. So the multicolors looks way cooler in person. Janet Fish has made a career out of being very bright. There's a lot of brilliant colors in her paintings. And so both of these artists are using extraordinary colors because they're so bright. And some people refer to it as surrealist color. So surreal is like beyond real. That's what that word would mean if you broke it down. So you're using color that is beyond reality. And the impact that it has, to answer number 17, is it adds extra energy. It adds extra energy to your artwork. So it doesn't look like dull and boring. It has like a bunch of energy going on with it. Hopefully that makes sense when you look at this slide. Number 18, realistic color. Remarkable realistic color. Ralph Goings is a famous painter that was a super realist, and yes, that is a painting. So, an oil painting, he was so good at painting that he picked like the hardest things to paint, such as glass and chrome, and just like made a career of these types of pictures. He did a lot of diner pictures, and there's chrome and glass, and it's all blurry in the background, and painting and coloring something to look blurry. I've literally never been able to do that. That's like just amazing. So, the impact that realistic color has on an artwork is just the awe factor. All right. So, if you're going to be a realistic painter, what you're really doing in effect, the effect that you have is the awe of how someone could do that, so masterfully. They're such a good craftsman that they can craft paint or pencil or whatever in such a way that it just is amazing. It's awe-inspiring. Last one, monochromatic. That's art that is based on one color. And the Picasso example is one of the more art teacher examples that teachers will use. Technically, it's not purely monochromatic because there is a little bit of brown going on, but basically everything else in the picture is blue. So monochromatic is when you take one color and you base your whole picture off of that color. And the impact that it has is it sets a mood. So each color in the color wheel kind of has an emotional reference to it. Like yellow is warm or bright or pure, maybe godly, in a lot of religious art. I don't know. I mean, blue is on here. Blue is considered sad. Blue can be stable because the sky is blue and water is blue, and those two things are considered stable. But generally, emotionally, you'd say blue is sad. Green is the color of like life, vibrancy, rebirth, I guess. So green has its own emotion, and it's like even though it's a cool color on the color wheel, emotionally it's like a warm color because something that's alive is green. So anyway, if you want to really make an emotion stand out in your art, you would possibly say, hey, I'm going to do monochromatic in order to really get this emotion to show up because this color has the emotion that I want in my art. All right, good stuff.